independent program paths. So we made a flow graph from the flowchart. Now independent path is any path, any route that introduces at least one new set of processing statement or condition. In simple sentence, new edge has to be included. That is the independent path. Every independent path must include a new set of edge, this arrow. So independent path must move along at least one edge that has not been traversed. For example, let us find out what are the set of independent path for this flow graph. First one is 1. We start with 1 and then we came here 11. This is the easiest path. This is an independent path. What can be the second path? Let me change the color. What can be independent path? Because we are making set of independent paths. So we are going to 1, 2, 3, then 4, 5. Then you can go to 10, then 1, back again, and coming to 11. This is path number 2. This is once again an independent path. Now coming to the third path. 1, go to 2, 3, then 6, then 8, go to 9, 10, 1, and then 11. Now you are able to see that every time we are taking a new edge, every time a new edge is introduced. Let me show you one more path. Okay, I'm taking different color. Okay. So now path number 4. This is one of the set of independent path. We start with 1, go to 2, 3, go to 6, then 7, then 9, then 10, and 1, and then 11. Again, one of the edges included, new edge is included. But there are certain paths which are not independent path. Because if all these path 1 to 4 has been taken, I'll make one more path and you will be saying by yourself that no, this is not a path because it is already including all the paths which we have already covered. So it is not a independent path. Okay, just see here. Because this path, as we start with 1, 2, 3, 4, 5, 10, 1, 1, and then we go to again 2, 3, coming back. This can be a path. 6, 8, 9, 10, 1, and then 11. So this is not. Why? Because this is simply a combination of already specified path 1 to path 4, and does not traverse any new edges. So path 1 through 4, which we have devised here, constitute a basis set for the flow graph. This is the basis set. Set is a combination of number of multiple independent paths. I hope you got the idea. Basis set is not unique. If you and me are making the independent path, your path may be different, my path may be different. So different basis set can be derived from a given procedural design. Cyclomatic complexity. How many paths to look for? Whenever we are trying to find out the independent path from a flow graph, how many paths to look for? The answer is cyclomatic complexity. Cyclomatic complexity is nothing but it will give you the test cases. How many test cases? So every time when we take the independent path, it should include an edge or a control path which has never been touched, which has never been traversed. So it is a software metric, cyclomatic complexity. It is a software metric that, because we are going to get the number, that provides a quantitative measure, again getting a number, of the logical complexity of a program. This flow graph has been made from flowchart or a PDL, and this gives you the cyclomatic complexity. So cyclomatic complexity defines the number of independent paths on the basis set, providing you with the upper bound of the number of tests or test cases that must be conducted to ensure that all statements have been executed at least one. So cyclomatic complexity is all about giving you the number of test cases or the upper bound, how many paths you have to take. So cyclomatic complexity can be computed in 3 ways. You need to understand how to make this flow graph, then only you will be able to understand cyclomatic complexity. So let us see how many regions are there. Regions are all the closed circuit and one which is not closed, means outside. So how many you see here? R1, R2, R3 and one R4. These are the first thing, 4. Now cyclomatic complexity can be computed by E minus n plus 2. E is number of edges, n is number of nodes plus 2. Edges are simply the arrows, nodes are simply the circles. The third way to compute the cyclomatic complexity is just have to find out the predicate node. Predicate nodes are those nodes from where 2 or more edges are coming out. Which are the predicate nodes? 2 or more edges are coming out. So you see the first node, 2 arrows are coming. So this is the predicate node. 2, 3, 2 are coming. Predicate node. 6, predicate node. Actually, these are the diamonds in the flow chart. So P plus 1, 3 plus 1. How many regions are there? 4. E minus n plus 2. This also will compute to 4. So the cyclomatic complexity of this example is 4. I'll just revise it. Cyclomatic complexity is number of flow regions. The 4 regions are there. So this is these number of edges minus nodes plus 2. So 11 edges are there, 9 nodes are there plus 2. This is 4. So now the third one, which is number of predicate nodes plus 1. So if you see these are, I'm just computing again the edges and nodes. So 11 edges, 9 nodes, and then predicate nodes are 3. 3 plus 1 is 4. So this all is giving you 4 value. So this 4 are the number of test cases. The value of this Vg is an upper bound for number of independent paths and number of tests that must be designed and executed to guarantee coverage of all program statements. This is cyclomatic complexity. Okay.